Hello and welcome to another one of these ADD videos. Today we're going to be looking at homogeneous equations, specifically the case in which we have imaginary roots. Alright, so the steps are the same as before. You find the characteristic equation, you solve for r and plug into the general solution. The only difference is for imaginary numbers, this is based off of alpha plus beta I, or you could write a plus bi if you don't like Greek letters. Don't get intimidated. So a equals alpha anywhere in my equation, and beta equals lowercase b. So the general solution to an imaginary root is going to be y equals c1 e to the alpha t sine beta t plus c e to the alpha t. A little further than anticipated, cosine beta t. Alright, so find your roots of your differential equation and go from there. So let's try it. R squared plus 9 equals 0. You either do the quadratic formula. In this case, I'm just going to subtract this over, and when I square root both sides, I get the square root of 9 times the square root of -1, so that's 3, and that's I. So if I were to write it in alpha plus beta I or a plus bi form, that would be my solution to R. So when I do that, I get y equals c1 e to the 0 t, there's your alpha, sine or cosine, I guess it doesn't matter, 3t plus c2 e to the 0. It's just some constant, that's why it doesn't matter. You're going to end up solving for them anyway given the initial conditions. So they'll go where they need to go, basically. Sine 3t. Alright, so that's basically it. Not too bad. You just got to practice a few of them. At first it just seems overwhelming because of this horrendous equation over here for the solution, but we can see that this one wasn't too bad. Alright, hope that's clarified things. You might get a solution where the first one's not 0. The only difference is that you would have an e in this answer. It would be something like, an e to the 2t, e to the 2t squeezed in there. Alright, so practice, 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 and thank you and have a nice day.